number. It's a number you can write in form of something to power 3. So the n cube is the cube number. So all you have to do is comma, which is a perfect cube. That's all. So if you don't need all these cube roots, so from here, comma, which is a cube number, from this n cube, alright, which is the perfect cube, I mean. Good. Need help? Yes? Raise your hand if you need help, anybody? We gotta move on. How did you get x squared plus 1? It should be x squared minus 1. Difference of 2 squared. Oh, it's x squared minus 1. That's
Oh.
Help? Anyone? Questions? Question. Okay. 6. Ah, I like that. Someone is attempting 6. No equality should be in the question. You should work on your inequality from A to Z. No equality. I know it to be a bit challenging, but it's quite simple. Quite simple. Anyone attempted 6? Okay, how about, let's start from 4. If you have attempted 4, raise your hand. Good. 5? Good. All right. Have you done 5, Clarissa? Or you are still on 5?
I'm trying to write it in a neater way.
Write what?
Write the equation in a neater way.
In a neater way. But you got your conclusion.
Yeah.
It's a perfect cube.
Yeah.
Good. So you've done 5 also. All right. So let's attempt 6. Let's attempt 6 quickly. Leo, question? Question 5. Question 5 is easy. Int has been given. The middle is x. If the middle is x, what are the other 2? Yeah, and increase by the middle number. What does that mean? So you have x minus 1, x plus 1, increased by the middle number. What does that mean? Increase is plus. So just simplify this. If you simplify this, your result is trivial. Is that 5? Okay. Have you finished 5? Where? Where's the problem? Okay, just write it like this. Good. That's it. So you just say yes. So I want you, I know most of you got something like this towards the end. Yes?
Yeah.
So all you have to do is, which is a perfect cube? No. That's equality sign. That's how you conclude. Because a square number is a number. If n is a square number, everybody look up. If n is a square number, then n can be written as k squared. If y is a cube number, then y can be written as maybe t cubed. So any number in this form is a cube number. Any number in this form is a square number. Okay? So it's just like having 2 to the power 3 towards the end. It's a cube number. You don't have to write it as 8. You just say, oh, this is a cube number, or it's a perfect cube. So that's how you just conclude. You don't have to write too much. Okay, 6, because of time, so I'm going to ask us to pay attention. Let's do the 6 together. Everybody, let's do the 6 together. Okay, are we here? All right, please pay attention throughout this. Inequality problems are not straightforward questions for students. You can see that already in the proof by induction. The inequality ones are the ones we have to crack our brains, think of ways to manipulate. It's like that. Even in Olympiad, like International Olympiad, inequality questions are very, very hard. But these are not even inequality questions when it comes to those levels of questioning. Anyway, so my point is we have to think outside the box. Sometimes it pays to look at where you're going. And also to use some of the implications that we have adopted. So I'll start by saying my a squared, or put it this way, if I want to get this I can multiply to both sides, right? I'm trying to do some reverse process to see what I need to get first, okay? If I want to get this, if I'm able to get, Verna, make sure we are here. If I'm able to get this, then we are good, right? Then we can think of divide both sides. So basically, if I need to get a squared plus b squared divided by 2, if I need to get this, I must conclude from this. Yes? But what can you say about this? What can I have previously to generate this one? Talk to me, please. You want to say something? What can I have in the previous step to give me this? Think of anything. A plus b squared? A plus b squared. I know, but that's like a step before that. Something must have given me this. That a plus b squared is giving you what? A squared plus 2ab. But you can see that my 2ab is on the other side. So it's not even a plus b squared. Think, guys.
Minus 2ab.
Good. A squared plus b squared minus 2ab greater than what? 0. Now what is this? A minus b all squared. Conclude the line. Greater than or equal to 0. So now think about this. Is this true? For any, it says for all a and b. Is this true? Is it true? Then this is your beginning. If you pick any two numbers and you find their difference and you square the difference, will the result be greater than or equal to 0 or not? When is the case where the result is 0? Speak louder. When they are the same. Remember, it never said A and B are different. It said for all A and B. So the case where they are the same and the case where they are different is included. So the first thing we will do, so you can see how I use my reverse thinking, if I may use that word, to solve my problem. So I need to start from here. Pick any two numbers, which of course has been picked for me. Subtract them. I know when I subtract them, it could be negative, it could be positive, it could be 0. Am I making sense? If the numbers are 2 and 4, the subtraction will be negative 2, right? If the numbers are 7 and 1, the subtraction will be positive. If the numbers are 8 and 8, the subtraction will be 0. So I have options. If I pick any two numbers and I subtract, I can get a negative, a positive, or 0. But if I square the difference, I have only two options. Either positive or 0. That's where we begin. So I will start by saying, let A, B be real, any two real numbers. Please pay attention, don't write anything. Let A, B be any two real numbers. Then A minus B all squared. Now, I've never indicated which one is greater, which one is less. I don't care. I've never ordered my A. So I don't know if A is greater than B or the other way around or they are equal. I don't care. That is why I can say this. Does that make sense? And this step implies that A squared minus 2AB plus B squared retains this, isn't it? And this step implies that A squared plus B squared will be more than or equal to 2AB. Yes? Then I can divide both sides by 2 and the result is out. So sometimes it pays to look at where you are going. Oh, this is where I'm going. How can I get this? Oh, if I can get this, then I can logically conclude this. Okay, how can I get this? Oh, if I can do this, I can logically conclude this. What does this mean? Sometimes you might need to add something to both sides to make it work. It depends on the situation. Okay? And here, so our conclusion now will be A squared minus B squared divided by 2 will be greater than or equal to AB. Who can tell me why we couldn't change it to less than or equal to? Remember, in inequality class, we tell you there are situations where the sign will change. But this is not changing. Yes? We didn't divide by negative, so we are safe. And this is the end of the proof. Any questions? So you have to use some of these tricks sometimes. This is new to us because of our level high school stuff. It's the first time we're having proofs. when you grow older, you get more matured mathematically and otherwise, some of this come to you naturally. You don't have to do this reverse cheating method. Okay? You know what to do already. So I'll leave you with the rest. They are quite easy. We could just take one together before we leave. Perhaps we could look at which question do we look at? Pick one question from 7, 8, and 9. Well, of course, we won't solve everything. We just pick one of them. Pick one question from 7, 8, and 9. Or should I pick one myself? Yeah? Okay. About 9 looks interesting, but it's a difference of squares of consecutive numbers. So I think that might be easy for you to do. This is sum, this is product. Maybe I work on product. Sum would be much easier for you, right? So let's work on product. This is different, so I believe difference would be easy too. So let's work on product. So now, product of odd is always odd, product of even is always even, product of, this is the cheapest of them, we don't need to worry. So how about we do product of odd? Okay, so we do A. Let's do A part together. So, can everybody see? All right. So the A part of this, proof. When you are asked to prove something, you start by writing proof. Okay? The proof of this goes this way. Nakita, can you see? Yeah. All right. Now the question says, prove that the product of two odd numbers, when you told is going to be consecutive. So we can't say x and, if they are consecutive odd numbers, if the first is x, the next will be what? X plus 2, not x plus 1. The odd numbers, the gap is 2. It's very tricky. When I do this in maybe Form 1 or lower grades, and we are talking about the sum of two consecutive numbers is this, find the numbers, word problems like that. After we do consecutive numbers and they have exercises, I give an example of the sum of two consecutive even numbers. Then they are able to see that the gap is 2. So if the first is x, the second is x plus 2. And some of them conclude from that point that because even numbers are divided by 2, that is why are divisible by 2, that's why I put the gap of 2. So when I ask them for odd numbers, they tell me x and x plus 1. Because they believe, oh no, there's something associated with 1 and odd number. When you divide by 2, give the remainder of 1. So there's a reason I always give that one as example and see who will fall into the trap. And of course, I always have clients every year falling into the trap, which is a good thing. Anyway, now, if there are two odd numbers, we don't know if they are consecutive or not. So we can't assume they are consecutive. So we can't use x and x plus 2 to represent the numbers. Rather, we use different variables. What is the format of an odd number? What does an odd number look like in algebra? Yes?
Maybe 2a plus 1.
2a plus 1. Okay? It will be an even plus 1. Every odd number is like that. So we say, let's the numbers be 2a plus 1 and maybe 2y plus 1. If I write 2b plus 1, I don't want you to think they are consecutive because a and b are consecutive letters. These are just variables, please. Do not draw unnecessary conclusion. Okay? You're probably a fan of English alphabet and you think, oh yeah, this must be 8 and this must be 10. No, not like that. Okay, so if these are the numbers, you want to show that their product is always odd, which means you must be able to express the product as what? 2m plus 1, where m is an integer. As long as you can write your product that way, you are good to go. So product means what? 2a plus 1, 2y plus 1 will be equal to, then you expand, right? 4ay plus 2a, well, it could be 2y first, plus 1. But how do I conclude that this is odd? What can I do? Karen? Factorize 2, thank you. So, factorize 2. Yes? 2ay plus a plus y. So this is the m that Lillian was talking about. Okay? So, if you like, you can try to write it as, which is 2m plus 1, which means you are represented the bracket with m. Does that make sense now? So if you do this, then you say, which is an odd number. And that is the end of your proof. Any questions? If it is an even, what does an even number look like in algebra? Just 2a. No plus. Just 2a. Because your so-called 2a plus 2 will be written as 2 bracket a plus 1. So that's like 2m. Okay? So if you are representing for all these questions, that's what you need to have at the back of your mind. So let's take pictures of this. Then we can go home and sort this out because we have 3 minutes before we are locked out of the building. I didn't come with my duvet, so I'm not going to sleep here till Monday. So let's take pictures.
You can always climb up.
Oh yeah.